In this video, I'm going to show you how to solve equations that have two radicals. Now, we know that when we square a radical, the radical disappears. It gets canceled off. So what we want to do is to move one radical on each side so that when we square each side, the radical will disappear. Now, remember to distribute or FOIL if you are squaring a binomial. So I'll put FOIL in brackets, since some of you might know the first outside, inside, last acronym. Now, after you've done that, you're going to simplify, and if there still is a radical, you want to isolate that one again, and then square both sides again. And then at the end, don't forget to check your solutions to see if there are any extraneous roots. Let's take a look at some examples. So here we have two radicals. So what we're going to do is we're going to move one on each side. So I'm going to move the negative 3 connected to the square root of y minus 1 to the right. So they are one term, so I'm going to move the whole thing to the right side. So from here, I'm going to square both sides. Okay, so when I square the left, I get y plus 3. When I square the right side, remember we have each of these terms squared. Think of this as there's a multiplication symbol here. So we have 3 squared, which is 9. And then the root y minus 1 is also squared. Now remember that the 3 is multiplied by this entire radical. So therefore, after I've squared it, the 9 has to be multiplied by the entire y minus 1. So please remember to put the brackets around the y minus 1. So now we have a simpler equation, and we're going to simplify. So the right side becomes 9y minus 9. And let's move everything to one side. Or not one side, we'll move the variables to the left, and we'll move the constants to the right side. So negative 12. Divide both sides by negative 8. So y is equal to 12 over 8. And then when we reduce, it becomes 3 over 2. So remember to state any restrictions on the variable. So we know that y plus 3 must be greater or equal to 0. So y has to be greater or equal to negative 3. In the second radical, we have y minus 1, and that has to be greater or equal to 0. So y has to be greater or equal to 1. Now, we don't need both of them. So if you take a look, one says y is greater or equal to negative 3. So if I drew a number line, that would be down here, and it's stating that y is greater than negative 3 going to the right. In the second restriction, we see that it starts at 1, but y is also greater than 1. So what we would say is that the second inequality is more restrictive than the first. So therefore, we don't need both, we only need the second one. Because it says that y is greater than negative 3. Let's say we have 0, and y was 0. Well, 0 works for the first radical, but unfortunately it doesn't work for the second radical. So we can't say that y is greater or equal to negative 3, and therefore we say that the restriction is y has to be greater or equal to 1. All right, let's do a check with our solution. So 3 over 2 is greater than 1. So we're going to put 3 over 2 plus 3, and then minus 3 times 3 over 2 minus 1. So inside the first radical, we're going to get a common denominator. So that's going to be 6 over 2 minus 3. In the second radical, we'll get a common denominator 2. So that would be 2 over 2. In the first radical, we get 9 over 2. In the second radical, we get minus 3 square root a half. Now, this is where we need to maybe combine. Actually, I forget these equal 0. And if I wasn't using a calculator, what I want to do is move that 3 inside. So remember, 3 moved inside would be root 9 to make it also a square root. And then a half still. And now I can multiply these two together. So I get root 9 over 2, and then minus root 9 over 2. And yes, indeed, this equals 0. So 0 equals 0, which means that that's good, which means that y equals 3 over 2 is our solution. Let's take a look at another one. So in this case here, we have the square root of 3x minus 5. We have another radical, 3x, and then we have a negative 1. So what I'm going to do is I'm going to move the negative 1 again to the right side. So it's going to be positive root 3x, and then minus 1 will be on the outside. So same as before, I have a radical on each side. I'm going to square both sides. Now, remember when I square the right side, I actually have to multiply it by itself because it's a binomial. So actually, instead of just putting the squared, what I'm going to do is I'm going to erase the squared, and I'm going to rewrite this as another 3x, or the square root of 3x, and then minus 1. So that will remind me that I need to distribute. So on the left, the square root and the square cancel. We get 3x minus 5. On the right side, I get root 3x times root 3x, which is 3x, root 3x minus 1, and another minus 1 times root 3x. So I get negative 2 root 3x. And then negative 1, I get positive 1. So when I multiply. All right, so now let's join any of our like terms. This is great. We have a 3x on each side, so I'm going to cancel that off. Let's move our constants together, and actually let's make this radical positive. So I'm going to move that to the left, so that will be positive 2 root 3x. I'm going to move the negative 5 by adding 5 to the other side, and I get 6. All right, so here I have a radical again, so therefore I have to square again. Now actually before I do that, I kind of want to move that 2, therefore that I don't have to square that 2. So I'm going to divide both sides by 2. So now I have root 3x equals 3. Now I'm going to square both sides. And when I do that, the left side cancels off, or the radical cancels off, so I'm left with 3x equals to 9. Divide both sides by 3, and x equals 3. So again, let's state our restrictions. So we have 3x minus 5 is greater or equal to 0. 3x is greater or equal to 5, and x is greater or equal to 5/3. The other restriction is 3x is greater or equal to 0. Divide both sides by 3, and x is greater or equal to 0. So in terms of which one is more restrictive, because this one starts at a higher number, 5/3, we only need the restriction here, which is greater or equal to 5/3. And we see that our solution x equals 3 indeed satisfies this restriction. Now, what I'm next going to do is then check our solution. So we're going to substitute 3 in for x. And remember that when we're checking, we always substitute it into the original equation. So I have 9 minus 5, and that's going to be root 4. And 3 times 3 is 9. So that all equals negative 1. And square root of 4 is 2 minus 3. And that does equal negative 1. Negative 1 equals negative 1. So that's great. So we can say that x equals 3 is our solution. All right, I'm going to show you one more example where we have two radicals again, where both of them are binomial radicals. So again, I'm going to move one of the radicals to the right side. Usually I like to move the negative so that everything's positive. So I'll move the 2x plus the radical, or the root 2x plus 7 to the right. Minus 3 is on the outside. And we're going to square this right away. Now remember, instead of squaring, I'm going to actually rewrite this as another 2x plus 7 minus 3 so that I remember to distribute. On the left, I get x minus 5. And on the right, we get 2x plus 7, multiplying the first terms. And then when I multiply the root 2x plus 7 and the negative 3, I have another one over here in the middle. So I'm going to actually end up with negative 6. And then the square root of 2x plus 7. and then negative 3 times negative 3 is positive 9. All right, so let's move everything that's, if it's a radical, let's move it to the left, and if it's not a radical, we'll move it to the other side. So we're going to move the 6 and then root 2x plus 7 to the left, and we'll move this x over here, so I get x. And I'm going to add a 5 to the right side, so 7 plus 9, and now I also have plus 5, so that's plus 21. All right, so again, I have a radical, so therefore I need to square it again. Now I have isolated my radical with my other terms on the right side. Okay, this time I'm not going to divide by 6 because the right side, the x plus 21, doesn't divide by 6 very well. So I'm not going to do that. So squaring the left, and again, we're going to square the right side. And I'm going to write this as another binomial to remember to distribute. 6 squared is 36 times 2x plus 7. And that equals x squared plus 42x. And then 21 times 21 is 441. 36 times 2x, we're going to do some simplification. 72x plus 252 equals x squared plus 42x plus 441. All right, let's move everything to one side. So 0 equals x squared. Moving and subtracting 72x from both sides, I get negative 30x. Subtracting 252, so 441 minus 252 is 189. All right, now this one is factorable, and I've played around with this one a bit. And I know that the factors are going to be x minus 21 and x minus 9. Now, if you don't know what multiplies to 189, that's okay. What you can do is also use the quadratic formula. So in this case, x is 21 and 9. So we're going to check our solution. Oh, actually, let's do our restrictions first. So x minus 5 is greater or equal to 0. X is greater or equal to 5. And we have 2x plus 7 is greater or equal to 0. 2x greater or equal to negative 7. X is greater or equal to negative 7 over 2. So in this case, x greater or equal to 5 is more restrictive because it has to be a positive number greater than 5. All right, so now let's do our check. So in this case, we have two solutions to check. So let's first check 21 minus 21 minus 5 in this first square root, and then 2 times 21 plus 7 equals negative 3. So 21 minus 5, we have the square root of 16. And then in the second radical, we have 2 times 21 plus 7, which is root 49, equals negative 3. So we have 4 minus 7, which is negative 3, which equals the right side. So that's great. So quickly checking the other one as well. We have 9 minus 5, and then minus 2 times 9 plus 7 equals negative 3. So we have a root 4. And then 18 plus 7 is 25. So square root of 25. So we have 2 minus 5. And yes, indeed, we get negative 3. So great. Both of these solutions work. So we have two solutions in this case. X equals 21 and also 9.